we are a company, Tupy is a company fully devoted to technology. The main part of our business, as I will show you to you, is the blocks and heads business, which I would risk to say that in the foundry, iron foundry business is the most technology intensive segment. We have been in the market for blocks and heads maybe since the 70s. We started with the growth of automotive industry in Brazil, but in its origin, Tupy was a company founded back in 1938, devoted to the production of fittings, pipe fittings. The automotive industry only went to Brazil in the 50s, and along with the growth of the automotive industry, we also grew. We manufacture blocks and heads, as I already mentioned, but we also we develop and manufacture parts that are fundamental to the structure of the vehicles in general, for steering, for braking, for suspension systems. And these are the crucial items in the vehicle that absorb the stresses along the life of a vehicle. This is a small summary. We have a 500,000 tons capacity. We are the largest foundry in Latin America, fifth largest independent foundry in the world, and number 2 in blocks and heads. We are labor intensive, roughly 7,500 employees, and as I already said, we're the Brazilian leader in engine blocks and heads, technology and quality leader, pipe fittings, and we also have some machining activity, but that cover only roughly 4 to 5% of our overall output. And there in the end of the slide, net sales of $740 million in cash generated $130 million. This is a picture of our facilities. We are very close to the sea. It's not a river, it's an arm of the sea that invades the land in Brazil. And this is a very big area, 1.2 million square meters, out of which only 172,000 meters are buildings. This is one of our facilities. It's in the southern part of Brazil, in the state where we have German colonization. And because of that, I think some of the strength that we have is our blue-collar people, very disciplined and committed with the business, very tough environment to work in, a foundry. I used to work in refrigerated places. I still work in the refrigerated places, but when you go into the manufacturing site, you see how tough it is to work in a foundry. Up to today, even in these days, it's a very difficult job, but we have very good labor and people committed to this company that next year will be 7 years old. This is the second site. It's a smaller site in the neighborhood of São Paulo, the biggest town in Brazil. It's much smaller. It's something that we took over from a company that closed and sold the foundry to Tupy and other activities to another groups. It's 120,000 tons a year. It's a much smaller plant. The shareholders structure. We have a very concentrated standard. The biggest 4 are controlling shareholders. They don't trade their shares. The biggest one is Previ. Previ is my former employee. I was an employee for Previ before. It's a pension fund. It's a big pension, biggest pension fund in Brazil. As of today, they are running assets or managing assets of around $50 billion, US dollars. And then you have Telos, a telecom company pension fund. BNDESPAR is a state-owned bank that is fully devoted to investment, either by credit or capital, long-term. There's a support for the companies in Brazil. Aeros is a pension fund for 2 airlines that no longer exist. So they keep the pension fund and some support to the retirees. And Bradesco is the private bank in Brazil, the biggest private bank in Brazil. And so out of the 100% of the capital, only 3% is floating in the stock market. Okay, Tupy is a public company, but very little float in the stock market. This one of the business areas, what we call industrial products. The fittings that are in the origin of the company, most of it, in Brazil, they are used mostly to equipment and machine construction, firefighting and gas systems because of high pressure required, and plastic do not attend the requirements. Very little these days for civil construction purposes because most of the civil construction was replaced by plastics. Because of our climate there, we don't need things that are resistant to frozen water, for example. Maybe it's different here in Sweden. Steel shots that we use in our own process, and for granites and marble sawing machines, and iron bars. But this is a smaller part. It's 15% of the overall revenues of the company, mostly in the fittings business. And the biggest or the largest portion is in the automotive products, as you can tell. Engine blocks, engine heads, crankshafts, exhaust manifolds, and machining also. And the applications, we have some illustrating slide following. Then for engineered parts, braking parts, suspension parts, some products for railroad fastening systems, and also machining. Here you see the illustration where our parts go in the passenger cars and also in the commercial vehicles. So the blocks and heads is really what we focus on. We have a very broad customer bases in South America. You can tell by the brands. Cummins, Mercedes-Benz is the biggest, is the largest customer that we have. Now we can no longer refer to a division of Daimler Chrysler Group, but only to Daimler, Mercedes-Benz, the brand, and then Ford, Volkswagen, Bosch, International, Peugeot, Scania. So I think the brands, they speak by themselves. Some of them are recovering from difficulties. Others need to make a lot of work. But in Brazil, as in general, I think that everybody is doing very well. Just for the sake of an example, the South American division of Ford is the best one in terms of results. We have in the NAFTA area also a broad base of customers. Cummins is the largest one, followed by Chrysler. Chrysler is a customer that we developed based on the shutdown of their foundry in Indianapolis some 2 to 3 years ago. We currently have no relevant business with GM, but we are developing an engine block, V8 engine block in CGI for GM. So we are recovering the business with them. And then the other brands, Jaguar, International, and so on and so forth. In Europe, we have very good customers as well, although the competition here is much tougher because we still have foundries in Europe. In the US territory, we have no longer any foundry focused on blocks and heads. It's different. We have very strong German foundries here, Italian foundries, so foundries in many different places in Spain, and so the competition is tougher. And you see in a slide coming up soon, the distribution of our sales favors much more the North American market than the European market, reflecting this different standard competition standard. Asia, although we are very far from Asia, we have customers in China, Cummins division in China, Komatsu in Japan, Kubota is a Japanese company as well. And you see FAW is a division, Wuxi Diesel. They have their own foundry, but they are not able to make some parts. I don't know for which reasons. I suspect that they have some difficulties in terms of development and manufacturing of more sophisticated parts, and then they go to Brazil and buy it from Tupy. You try, and KBX is Kalyani, is a braking business in India. As I announced before, you see NAFTA responding for more than 45% of our sales. So it's even more than Brazil. The market in Brazil is much smaller, and we export roughly. Last year, we exported roughly 58% of the overall output of the company. So if you want to be linked to technological development, and you have to be where it's held. So it's not in the Brazilian market. The Brazilian market is not as sophisticated by the European and the North American market. So we have to work hard to conquer our space in these markets if you want to be linked to technological development. In Brazil, we are a step behind. We basically import technology. So the OEMs established in Brazil, they work according to the decisions made in the countries of origin of their headquarters. So but to be in the global market, we have to have structures. In Brazil, we have our headquarters, as I mentioned, in the southern part of Brazil. But we have company in the US. We have a TAFCO, which is Tupy American Foundry. And we also have a subsidiary here in Europe, in Germany, in Munich. We have to hold this structure and companies abroad, because the governments of both the US and in Germany, they would not allow us to keep this business as just RIP offices because of fiscal issues. So they kind of oblige us to hold the business under the form of companies, and that's why. But they are basically sales offices and support to the customer, engineers, and we are in the US, we are here in Europe, we are in Italy. We have a representative to take care of the Italian customers, Japan, China. So we're an international service organization, as the headline of this slide shows. And this is basically the rule of the game. If we do not work like this, we cannot survive. So this is a very brief presentation of Tupy, and now we go to a more specific discussion, or very quick presentation on what the materials, what are the trends in terms of materials, and what should it bring to CGI, to the future of CGI, and why we are so enthusiastic, me, Roger, Steve, about CGI. First of all, I think that there is an issue in respect to costs. So if there's a growing concern, as it's written in this slide, from the OEMs and engine producers in respect to are the customers, the target customers, really willing to pay more for something that do not add any benefit, or they do not perceive as adding benefit? If we look at this issue on an isolated way, this is clear that cast iron and CGI, they have an advantage over aluminum, which is the main competitor for blocks and heads industry, and that's what we are discussing here. So this is a comparison between the competitiveness of aluminum and cast iron or CGI. So we should expect cast iron dominance in the vehicles, because cast iron is cheaper than CGI, where the driver is price. It's price for the target customer. And on the other hand, if we are looking for performance attributes that the customers, the final customer, I'm willing to pay for that, aluminum will be stronger than cast iron, and second would come CGI. When you look for combustion optimization, and this is another side of this discussion, because it regards to pollution, for particulate matters, for and other elements of pollution, you will see that CGI is ahead of both aluminum and cast iron. Second, it comes CGI. And something that is very important these days is the discussion on alternative fuels or environmentally friendly fuels. and the penetration of these fuels in the market, which is the last point. And then you'll see once again CGI being the leader in this discussion, followed by both aluminum and cast iron. So you would see cast iron, that's our view, in price-driven applications, so where price is very important for the final customer. On the other hand, in the other extreme part, you would see aluminum where the customer is not concerned about price, so wealthier people that would not be caring about the price they would be paying for something that not necessarily adds something in terms of performance. When you look, and then the point 3 and 4, the points 3 and 4, they are related to the current discussion in respect to pollution, and then you see CGI as being the best option or the best response where you need more efficient combustion of fuels. So, and the fourth point in the square in the right, in your right side of the slide, this is very important to stress this point. So, it regards to profiting the existing structure of investments to make the same thing. And when we talk about foundries, for example, we can make CGI with both basically the same set of assets that we use to make gray iron, common gray iron. And this is very important because this allows us to produce a new kind of alloy without having to invest lots of money. And if you look at this picture and you expand this picture, we start thinking about new technologies or hydrogen cells or things that are very fancy, electric vehicles, but do not attend to the basic principle of using the basic structure that we have in terms of fuel distribution and all the investments that the OEMs have done for the purpose of producing their current products. So it's very important. This is a very important point in the overall picture. Now we turn to diesel. Why do we turn to diesel, and why am I stressing the diesel in this presentation? Diesel represents, I think, the best opportunity in the short and medium run for CGI, but not meaning that gasoline-driven engines are not an opportunity, but maybe more from the medium to the longer term. Why diesel? We have some drivers for that. First, the new and structured emissions legislations that require a higher level of efficiency in terms of combustion of engines. We have also some new technologies applied in the diesel engines like common rail that provide a smoother operation. We know that in the US market, for example, Americans are very reluctant to diesel engines because of, how would say, the movement, noise, and also vibration. And they have been reluctant in terms of diesel engines because of that. But on the other hand, we have, as I mentioned, the stricter requirements in terms of, more strict requirements in terms of pollution. We can say of carbon dioxide, we can talk about NOx, and we can talk about particulate matters. But to run and to have the level of efficiency in terms of combustion, these engines have to work on very, very high pressures, which means that the material in which they are made is crucial. So what we see and what we have been told by many industry engineers is that resistance to high pressure is becoming more and more critical for the new engines. Well, where is CGI positioned in this picture? First of all, CGI is more resistant than aluminum and cast gray iron. So you can have a material that allows you to work under these more strict conditions, and being more resistant, it means that also you can build engines with lower wall thickness. I think that you are familiar with this discussion because it's core to CGI. Just for the sake of an example, we could produce with the same power output an engine with 1.2 to 1.4 liter that compares to a gasoline or cast iron engine or aluminum that would require a higher volume, 1.8 to 2 liters. So, and aluminum in this picture is becoming in a more and more difficult situation because the higher the pressure, the thicker would have to be the walls of an aluminum engine block to stand the higher level of pressure. So I think that, and this is not because this is everybody in the OEMs and everybody that we have the opportunity to talk about, it's a common opinion that a higher pressure is something that in the foreseeable future is going to be more and more important for building engines, which means that in this sense CGI is very well positioned for the future. We are once again talking about diesel engines. When we expand the discussion, it's kind of summary, this slide. We look at diesel engines, and then once again a comparison between aluminum CGI and gray iron. If you go to diesel engines with V-shaped diesel engines, we have CGI as a possibility for a dominant material. This I can tell you because we are involved. Some customers I cannot tell the names, but we're involved in quite a big number of projects related to V-shaped engines, most of them for the North American market. You can make your guesses just trying to link. There are not so many brands that are in the market right now and that are devoted to iron engines. So we see little room for competition or competitiveness of aluminum against CGI when you look at diesel engines V-shaped. When we go to inline diesel engines, we see aluminum being like limited to those segments of cars, higher value, higher prices, and where materials, the internal pressure is not an issue. We see inline in commercial vehicles also we see CGI as the dominant material for the future, and we also have some we can tell, some others we can't, projects. One is the start of production is expected to next July, is MAN, but we have other projects. And gray iron in diesel, where price is the driver, will be dominant, as I mentioned before. When you go to gasoline, V-shaped, luxury sports cars, there's a situation, thank you, Berto, where the V6 models are right now dominated by aluminum, but this is not something that I would expect in the longer term. I would expect, even for gasoline engines, new battle probably between CGI and aluminum. It depends a lot on Rogers' activity in respect to machining and to what extent machining will progress in terms of cost or lower cost for the companies, and how can we work to convince the engineers of OEMs to go back to iron in this segment. We see space for CGI also in the gasoline V-shaped engines. Now I'm going to the right or to your left. When we look very sophisticated engines like competition engines. Like we, for example, we have together with SinterCast, which is our partner, we have an engine that we produce for Toyota, and that is used in NASCAR competition, but this is a small engine, very, very high output in terms of power. And in gray iron, we see in very high scale pickup trucks and SUVs with V8 engine configurations, space for gray iron, common gray iron. In the inline, once again, aluminum, it depends on the sensitivity to price. Where the sensitivity is low, aluminum probably will keep as a dominant material. And CGI, once again, depends on the requirements of resistance to pressure, or requirements for the material, engines where pressure will be high. When you look at gasoline, which is here, this is not to say there is not an opportunity here. Once again, it depends on how are we going to be able to convince people to move from aluminum in the gasoline, since the overall cost is something competitive. So the overall cost, I mean, foundry, casting, and machining. So I think that Roger will talk about machining issue, so I won't invade his arena this time. So a new summary talking about vehicle cost and consumption efficiency. And by this too, we refer to total cost of ownership. So how is it today? Today, diesel engines are still more expensive than gasoline versions. On the other hand, the efficiency of a diesel engine is estimated to be 30% higher than the gasoline vehicles of similar output. So what's the relative input? It's very important. This issue, total cost, on one hand, you have an engine which is more expensive in terms of the initial investment that you make. But on the other hand, it's much more efficient in terms of consumption. So diesel advantage here is big in respect to this point. In terms of performance, diesel engines, they have better torque and better acceleration, and noise and gas emissions are similar to their gasoline competitors. And in terms of pollution, less pollution than gasoline competitors in terms of carbon dioxide and nitrogen oxides. So this is very important. I think it's the most important point, but this point here is becoming more and more important. So when you look at diesel has, this is our assessment, diesel has big advantage over gasoline engines. And the biggest opportunity, or the great opportunity, is in the US market. Of course, here in Europe, you already have a predominance of diesel in your fleet. So the greatest opportunity is in the US market, where we expect it to happen probably from 2009 on. 2008 starts, 2009 on. Finally, I have a kind of, this is an approach that, by the way, was created by Steve. So the waves that we have, he is going to refer in later on to this, but we have this wave 1, where V-diesel engines for passenger cars, luxury segments beginning in Western Europe. As an example, we have all these, we have Jaguars using CGI engines. We have the wave 2, we are like starting it, or commercial vehicles. We have MAN, as I mentioned, but we have other customers here in Europe developing this. There's one important point here. Commercial vehicles, just for you to have an idea, a CGI engine for a truck, big truck, the weight is around 100 to 120 kilos lower than a gray iron engine. It means that for the same level of output, this is weight that you save and you can load with things that the trucks carry, and it means cash flow for the operators. So it's an important difference. Diesel engine, wave 3, I think it's going to start in 2008. Our project with General Motors, for example, is expected to start in the second half of 2008, but it grows substantially from 2009 on. Inline diesel, for passenger cars, I think that we have to work a lot on it to convince people in the OEMs that this is a good solution, and we have technical arguments to do so. And then we have the wave 5, which is gasoline engines for different technologies, even for hybrid cars, because you can build a smaller engine if you want to. You need to have 2 engines in a hybrid car. So the smaller the engine, the combustion engine, the better for your space, for design and for the sake of profiting better the overall space. So we think that we have something that will require a lot of work, but is something that we really believe in. We already have daily production of CGI in Tupy for the current customers. And CGI and diesel is core to our strategy. So this is the way we see the future. I think that CGI is, from our view, and I think Roger will say the same, but is a dominant for the diesel engines in the future, no matter what the shape, that's in the long term. And there's a lot of space for development in the gasoline market as well. So unless people in the aluminum industry create something very that would bring a breakthrough, I think that they will face tough times, as we faced tough times when the aluminum invaded, let's say, the arena of iron that was the dominant material for engine blocks and heads construction. Some few years ago, we were like 100% of the business, and now they have a very significant position. But this is, I think, our counter-strike is called CGI. Thank you very much.